Hey guys, sorry. It's at night and I have some really crappy lighting and I don't have anything to fix it with, so I'm sorry about that. I'm gonna go ahead and try to give you some decent notes for the the beginning of statistics. This particular video will go for topics 1 through 8, I believe, and then I'm going to do 9 through 15, and then or 9 through 16, and then there's a third video will take up the last three, and then I'm going to jump to a YouTube video for I think a guy does a more entertaining uh, description than I would. But a lot of statistics uh, is basically just making sure or attempting to make sure that your biases don't come through. Um, what we perceive is a group of like everyone. Like if we want to survey a specific group or we want to survey random people, the idea is that you're always searching to get the best description of random. I don't feel like it's in here, but there's also a general acceptance that any study that has less than 100 people in it doesn't really like hold validity. Like we need more people. So you need there's certain parameters for studies. Anyway, the whole deal with statistics, I said this in one class yesterday, but Mark Twain said there are liars, there are damn liars, and then there are statisticians. Because what people do with numbers is they can play with numbers and try to make them say what they want them to say. And we are seeing so much of that go down with COVID right now. And it's fascinating. It's fascinating mathematically. Interesting enough, when COVID started, I did take pictures of like the daily increase, thinking, oh, maybe this would be interesting to graph one day. But then it just kept getting super duper duper exponential. And then I was like, okay, after about a month or maybe like 3 weeks of like taking daily pictures, I was like, okay, this data is going to be out there and everybody's going to see it. It's not like I'm doing something new. Somebody else is doing it and doing it better. But anyway, I think it's really interesting, and pay attention whenever you hear anybody say anything about numbers. Ask what the source is. It has to be a good source. If it's oftentimes a group that has been paid by a group that wants to get the data that they want. There's a lot of that going around too. So you keep with big studies, you keep with reputable reputable research organizations. So always research, and don't trust when somebody says they said this. They said that 3% of this. You're like, or I guess one of the things that made me quit Facebook recently was that somebody was like saying that 9% of COVID patients died. No, not 9%. 9% of patients who died did not have pre-existing conditions. And then they basically were saying, like, who cares about everybody else? It was the weirdest thing. I mean, like, talk about taking data and screwing with it to try to get your point of view across. It was weird. Anyway, that's my little lecture. I'm trying to be careful and be aware and check to see where things are coming from and what they really mean. That's all. All right, I'm going to try to do this for you guys. All right, so the first topic is choosing an appropriate method for gathering data. Interesting, they say problem type 2. Hey, you didn't have to do problem type 1. So it says Central High wants to estimate the number of seniors who plan to go to a four-year college. Okay, so if you're thinking about this as far as high school, you want to estimate the number of seniors. Now, at your school, it'd be so easy to ask every single senior, but imagine at a school that has like 1,000 seniors. That's going to be a hard task to do. So, which of the following surveys would best represent the entire population? And that's the key word right there. We're trying to get a sample that would represent the whole population. So 50 honor roll students are randomly selected from the senior class. 32 plan to go to a four-year college. Okay. Now, what makes this a little bit skewed, you guys? Think about it. And it's this word right here. Honor roll. They're not picking random kids. They're picking the top kids. Okay. Which brings me to, real quick, another little aside. Until recently, like in the last, I'm going to say maybe 30 years, 20 years, which sounds like a long time to you guys, but it's not research-wise. There was so much data missing because they had only done a lot of data studies on men. And so a lot of data on women wasn't there, like for heart disease and stuff. It was really interesting. I guess they were just thinking about men. It was weird. Anyway, okay, 50 seniors are randomly selected. 29 plan to go to a four-year college. That's not bad. There's 50. So at least they're randomly selected, right? Let's see this one. 50 Glee Club members are randomly selected. Okay, 45 plan to go to a college. So obviously this Glee Club and this honor roll skew it. This is going to get you the arts. This is going to get you academic. This is the best one. Okay. Then it says there are 950 seniors at Central High. Using your answer from Part A, estimate the number of seniors who plan to go to a four-year college. Okay. I'm going to tell you this is going to happen again and again and again, and it's about setting up a proportion. Those of you that understand percents, you can do it your way. If you know how to do it percents, I'm not going to stop you. But the way that it works is, okay, a proportion is always a piece out of the whole, okay? And a percent is always what we are trying to compare it to. And so when we're looking at percent, it's going to be a piece out of 100, which just isn't, but that's what that one is, piece out of the 100. And in a sample size, a proportion would be would be achieved, I guess you want to say, because they have the same proportion. If you picked your sample size right, the small sample piece out of the whole would be equivalent to the piece out of the whole of the larger sample. Okay, so this would be the sample, and we're going to try to help it represent reality. Okay, so they say, we're going to use this one. Okay, and we're going to say 29 plan to go, 29 out of 50 plan to go to a four-year college. And then now they want to know, what does that mean out of 950? So 950 is the total. So we put it on the bottom and we are looking for how many. So that's when you cross multiply and you would get 50x is equal to 29 times 950. And then once you do that, you would divide both sides by 50. And then you can just enter that in on a calculator. 29 times 950 divided by 50. I'll do that right now. I'm going to grab my iPhone real quick right here. Here it is. Let's see. Oh, my iPhone died. You guys, my iPhone died. Oh, okay. Here, I'm going to plug my iPhone in. Anyway, you get the idea though. My iPhone's so dead that it's going to take a moment to come back to life. So I can't even do it. And I can't leave to go do this, but you get the idea. I'm not going to worry about actually multiplying this out. You know, I could do it by hand, y'all. I'm not scared of by hand. I guess I could just do it like this. 5 goes into 9. I could go 50 into 950 is going to be, what is that going to be? 2, 4, 6, 16, 17. Is that correct? 17? Okay. 900. I could just do that. Divided by 50. Wow. Sorry about that. You cancel the 1. 5 goes into 9 once. 5, 4, 40. 19. 5 goes into 48. 18. 18. Nah, it can't be 18. Oh, that's because I put 9. See, look, you always got to evaluate. This is the problem with writing those nasty. So hopefully by this time you guys went and got your calculators and you did this by yourself. This is how you divide. I can cancel out the ones. Okay, I'm going to bring this down. There, it's 19. All right, So this is 19, and I could just do 19 times 29. 19 times 29 is, and it's funny, there's lots of ways to estimate this, by the way, if you wanted to, like, 81. Don't talk, Miss Baca, don't talk and work at the same time. It's a scary time. 18, 26, and then 29. Sorry. I really wish look, my iPhone's coming back to life. Sometimes it's just not all that fun doing this basic math. Okay, 29, I got 1, I got a 5, 15, 1, 551. So basically they're saying that 551 students are going to go to a 4-year college. All right, now you ask yourself, does that make sense? Think about that. It's 29 out of 50, which is almost 3/5, right? Meaning like it's more than half. It's more than half. 25 would have been half, right? And 950 is almost 1,000, and 550 is a little bit more than half of 950. So yeah, that makes sense. Always check your answers for like sensibility. Do they even make sense? All right. So now we're going to take a look at expectation. Okay. Mrs. Simmons is a librarian at Westside Library. In examining a random sample of library books, the library's book collection, she found the following. So here we are, 946 books had no damage, 100 had minor, and 29 had major. Based on this sample, how many of the 57,000 books in the collection should Mrs. Simmons expect to have no damage? All right. So again, we are looking at, this is the sample. Okay, this is the smaller sample. So we're going to look at, in the sample, we're going to compare the sample, and then we're going to look at the expectation for reality. Okay. In the sample, there was 946. That's the piece. Now we need the whole. Okay. Whole. What's the whole? Well, you have to add all of them together. 946 plus 100 plus 29. So that would be 1,046 plus 29. 1,046 plus 29. You get 1075. So that's the total number of books in our sample size. But they're asking how many out of 57,000. So that's the whole of the library, and we're looking for X. Again, you would just cross multiply and solve. Okay, and for those of you, I got my phone is back online. I will just do this real quick. I got a calculator handy here. All right, so you go 946 times 57,000. Feel free to do it with me. Wow. And on this side, we get 53,922,000 equals 1075x. And then we divide by 1075. And then you end up getting x is equal to, divided by 1075, 50,160. And then ask yourself, does that make sense? Does that make sense? 50,160 books. Okay, we're looking at, it's less than 57,000, so that's good, but it's the majority. And look, this is the majority as well. So it makes a lot of sense. So again, you're just going to be setting up a lot of proportions with these. Okay. All right. This is a frequency distribution. A frequency distribution is just a tally chart. Okay. So this is 9 shoppers. Okay, here are shopping times in minutes of 9 shoppers at a local grocery store. Complete the grouped frequency distribution for the data. In the distribution, the frequency of a class is the number of shopping times in that class. Note that we are using a class width of 6. Okay, so for now, here's all you need to know. 15 to 20. You need to find how many are 15 to 20. And there are 3. Okay, so you're going to go 3. Okay, then 21 to 26. Okay, And we are looking at 21 to 26. I see a 25. That's 1. And then 27 to 32. 1, 2, 3, 4, 5. 5. I mean, a lot of times this works out like this when you're actually collecting data. You do that whole like tally chart. Okay, but then you are actually just going to put it, and that's as easy as it is. Okay, that's it. All right, moving on. Let me make sure of that. Wait, hang on a second. I'm pretty sure that's all that was. It's not like we do frequency 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 out of 9 is 1/3. I wonder if they're okay. Let's see. Wow, I can't check this out real quick. So basically, you're going to count. I guess the only other direction I could give you is you're going to count how much that occurs. I don't know if they're looking for the decimal now that I say it. They might be looking for the decimal out of the total. There are 9 total. Okay. Not 3 out of 9. We're going from 19 to 30. Okay. Shoot, I want to unplug because I wish I would have done this. I'm going to stop it. You guys want to pause it and make sure. Okay, y'all, I was right. It's just as simple as that. Sometimes you're like, it couldn't possibly be this easy. It really is that easy. It's really nothing more than that. Okay, and just so you understand, the class width of 6 is there. This is the 6 numbers: 15, 15, 16, 17, 18, 19, 20. There are 6 numbers. That's what that means in each of these distributions. 21 to 26, there's 6. 27 to 32, there's 6. That's what that means. It doesn't have anything to do with the answer, but that's what that means. Okay. All right. Take a look at this one. Okay. These are the hottest recorded temperatures. Okay. For each of the 15 cities throughout, like 15, each of 15 cities throughout North America. Okay, so here you go. The one thing that they do with data like this is they don't put it in order. Normally, we would reorder this and put it like from lowest to highest. It would make it a lot easier to collect the data. But let's go ahead and do it. You are going to do 98 to 102, and the distribution width is 5. The class width is 5. So they're going 98 to 102. So right here, you've got 98. Not there. 100. Not there. 101. That's the only ones I see. So I see 3. And then 103 to 107. That's going to be here. 103. Here, 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 here. Okay. So 1, 2, 3, 4, 5, 5. And then 108 to 112. I'm going to change colors because I can't see it. 108 to 112. That's 1, 2, 3. Yeah, just 3. And then 113. You guys, it's so hot. Oh my goodness. Okay. Okay, 116, 113 to 117 is going to be right here. I'll do the blue. Okay. 1, 2, 3, 4. And that should be add up to the right amount. Okay. And then it asks you to construct a histogram. A histogram is a bar graph. So 98 to 102, you're going to just do a bar graph. It goes 3. So it's to here. It'll be fun on Alex, you guys, because I think you'll be able to play with like little graphing tools that'll make it look pretty. Okay, and this one goes to 3, and this one goes to 4. And that's it. All right, I know that's not hard for you guys. Moving on. What happened? Where's my thing? Where's my problems? Where did they go? What happened? Y'all, where did they go? They're gone. That's so weird. Okay, I have to go make another tape. I apologize. This is weird.